So a very warm welcome to you all. My name is Liz, and this is Charlie.
Hi.
And we're members of the NRICH team here in Cambridge. We're delighted to have you all here this afternoon. We would like to say a big thank you to Trinity College, part of the university, because they have funded the webinars so that they're free for you to come along. Some of you may be joining us because your school has become a problem-solving school, or perhaps you're thinking of becoming one. Maybe you're not necessarily here for that reason. Whatever the reason is, you're very, very welcome. If you've joined our webinars before, you may know that we're running quite a series of them at the moment. And I'm going to just share my screen to give you a bit of a sense of how today's webinar fits into this series. So I am hoping that you can see the secondary teacher homepage of NRICH. You may be aware that in the last year and a half or so, we've restructured the page. So, we've restructured the whole website. However, one of the main differences is to this, the landing pages. So the secondary landing page and the primary landing pages are analogous, but they're identical. So part of being a good mathematician is, of course, having a good understanding of mathematical concepts, being fluent with mathematical ideas. And so what we have got in this first box here is a way into the site to find problems via their curriculum content. But that's only part of the story. A good mathematician can also think mathematically and brings to bear those mathematical thinking skills, such as when being faced with a new problem, you might do some exploring, some noticing, which might lead to a bit more systematic working, and then some conjecturing, generalizing, and eventually some reasoning, convincing. And actually, we've just completed a series of webinars which are focused on the five main parts of thinking mathematically. We'll show you where to find recordings of all those webinars at the end. But today, we're just starting a new series of webinars because, as well as having mathematical thinking skills and a good conceptual understanding, having a positive attitude towards mathematics and towards the learning of mathematics is key for our students to thrive. So if I just click on here to give you a little bit of an overview, we've identified 4 parts to having a positive mindset. Today, we're focusing on the first of those, so being curious, but we will go on to look at being collaborative, being resourceful, being resilient. So, Charlie, we're focusing today on being curious. So I guess what we'd like, a curious learner is going to be one who is therefore more motivated, more willing to learn, and perhaps if we can get, those moments when you're working on a problem and you kind of go, ooh, and wow. And then if you're driven to ask why, then I think this is what we're aiming for. We're tapping into students' curiosity.
Yes, I think I've sometimes mentioned to students that, of course, good mathematicians are good at answering questions, but actually another sign of a good mathematician is that they're good at asking questions, because that is the springboard to some mathematical thinking, mathematical activity, to hopefully some new discoveries and so on.
Right, I'm right.
So maybe we should start with something that's
I think
easy to express.
Okay, good idea.
And because many teachers possibly don't realize that we've published lots of posters.
Yes.
So if we go to the secondary teachers page and scroll down a little bit, there is a link there in the resources to the posters.
Fantastic. Okay.
And a lot of teachers plaster their classroom, wallpaper their classroom with our posters, or have poster of the week, or and there's one that we thought might be nice starting point.
Yep. So you can see, I could narrow this down to a particular age range if I wanted, but okay, let's just scroll down. It gives you a sense of what we've got here.
Make 37.
Make 37. This is the one we're after. Okay.
Yes.
So if we click on here, this takes us to a page which looks a bit like this. So
there's a link to the actual problem,
which is this one here,
which gives you a little bit more detail than you're going to get in the poster. But I think for the purposes of today, the poster has enough information.
Okay, so let's click on that and make it a bit larger on the screen. Here we go. Oh yeah.
Okay.
Nice.
So we've got 4 bags. One bag's got lots of 1s. Another bag's got lots of 3s.
Yep.
Another's got lots of 5s. And then there's a bag with lots of 7s.
Okay.
And the challenge is this. We'd like you to pick 10 numbers from the bags. So you can pick any 10 numbers. If you don't want to pick any from one of the bags, then that's all fine.
Okay, so I wouldn't have to pick a 7 if I didn't want to. Okay.
You don't know, but you do have to pick 10 altogether.
Exactly 10.
You can't just pick 6 or 7.
Okay.
And you can't pick more than 10. And the challenge is select 10 that will add up to 37.
Okay.
And when you've done that, perhaps in the chat, post which 10 you selected that gave you a total of 37.
Okay.
And we'll be quiet for a minute or two while everybody has a go at that problem. Gone very quiet, Liz.
It has gone very quiet. Has anybody found 10 numbers? Oh, maybe we've got a solution here, Charlie. We've got 1, 7, 2, 5. So that would make 17, I think. 6, 3, 17 plus 18 would be 35, 36, 37. I agree that makes 37. 1, 2, 3, 9. I'm not sure, David, that you've used 10 numbers. Yeah.
11 numbers.
I think it's 11 numbers. But
and
very close.
And you, Liz, managed to do it with 9 numbers.
I did, but I didn't get 10. I didn't manage to make it with 10. So in a classroom scenario now, Charlie, I guess what we'd be doing is we'd been giving children quite a long time to do some exploring. We may be doing exactly like we just did. We may be checking some solutions that come in to see whether they have made 37.
It seems like a fairly straightforward challenge. Stuart in the chat has been saying he doesn't think it's possible, and he's also worked out why it's not possible. I'm not going to say what he's written, so in case anyone wants to think about it, but this is not being able to do something which initially seemed fairly straightforward must, or is very likely to engender this kind of reaction. Wait a minute, what's going on here? Why is this happening? I want to understand. Why is this so difficult? I thought that, Charlie and Liz were going to be, nice people. They were going to start with something straightforward.
Accessible.
And what's going on here? Have they given us something that's impossible to do? Now, we're not going to go into the explanation now because this is about curiosity. And if we get bogged down in each problem, analysing it and explaining and so on, we're only going to be able to do 2 or 3 problems. And I think we've got 7 or 8 problems listed.
Yes.
And we're already 10 minutes into the webinar. So we will be putting links to all the problems that we're going to be discussing. And so you will get a chance to think about them in a bit more detail and with your colleagues.
Yeah.
So apologies if we're going to leave a few things hanging in the air, but we really do want to concentrate. And hopefully they're hanging in the air and they're leaving you curious to find out more, because that is the essence of what today is about.
Exactly.
So
well, that's whetted our appetite, Charlie. Shall we have a go at another task?
Okay, so you talked about going to the secondary teachers page.
I did.
And having 3 blocks.
Yeah.
Whether
so we're back here. Yeah.
Yes, and on the left-hand side, curriculum linked problems.
Yes.
And that is what a lot of teachers know about, because we have a curriculum mapping document which lists our favorite, richest tasks to the curriculum.
Yeah.
So let's have a look at the curriculum mapping document.
Okay.
And I think I'd like to start by going to the algebra page.
Okay, so the default page is the number.
Yes.
Okay, so algebra is the next tab along. Okay.
And in patterns and sequences,
right at the top here,
we've got a problem called Charlie's Delightful Machine. And the reason we want to talk about it is that it's got a new interactivity,
which we're very excited about.
Yes.
Very excited. Okay, here we go. Right, Charlie. So what's going on here?
So let's just reset it so that we just start afresh. Okay. We've got a 0, and the 0 is lighting up the yellow and the red light bulbs. And I'm going to ask you, Liz, to be quite systematic.
Okay.
And keep adding 1 every time.
Right.
And seeing which numbers light up which light bulbs.
Okay.
Now, we might ask all the participants to engage in some thinking about this.
Yeah.
So I'd like to suggest that everybody who's participating makes a note, keeps a table of some sort, so that they can refer back to the results.
Yeah, okay, brilliant.
So I'm going to...
Okay, so we know 0 lights up yellow and red. So
yes, and all the light bulbs are yellow, red, blue, and green.
Okay, all right. So I'm going to, as you suggested, I work systematically. Now, students won't start being systematic necessarily, but we're going to go straight into for the systematic approach. Okay, so 1 lights up green. 2 doesn't light up anything. 3 doesn't light up anything. Oh, I beg your pardon, I missed 4. 4 doesn't light up anything. 5 is blue. 6, nothing. 7, red and green. Ooh, okay, shall I keep going?
Yes.
8, nothing. 9, yellow. 10, nothing. 11, blue. 12, nothing. 13, green. 14, red. 15, nothing. 16, nothing. 17, blue. 18, yellow. Perhaps shall I go up to 20? Okay. 19, green. 20, nothing. So that's given a little bit of data for us to work with.
Now, I think I know what the rule is for red, because...
Oh, which light bulbs lit up red, Charlie? I'll just pop it in the chat, and then we'll so we can remember.
0, 7, and 14.
0, 7, and 14. Okay. So
multiples of 7.
Yep, looks like it. So if I did 21,
I'd expect red to light up.
We'd expect red to light up. Let's check it. Yes.
And I might also try like a really large number. 721.
Okay.
And red. Okay.
Fantastic.
Now, one of the new features of this interactivity...
Oh, look, green is also lit up.
Okay, I won't make a note of that one. But one of the new features of this interactivity is that we can check our answers.
Yeah, well, shall we go in confidently?
Yes.
And check, right. Oh, check my answers, please. There we go.
Red,
we're saying is, so we're thinking they are multiples of 7. So actually, if I'm going to, it's 0 more than a multiple of 7 and 0 less than a multiple of 7, because they're exact multiples of 7.
And we can submit the answer.
And we're given a little green tick. So we know that's correct. Okay, I'm going to go back so we can carry on experimenting should we wish. Oh, and we've got a suggestion for the rule for green here.
Okay, so do you want to write down?
Shall I write
Green
down
was
green?
1, 7. So Elizabeth thinks she knows the rule. 1, 7, 13, and 19. And what Elizabeth thinks, and yes, Elizabeth is right. These are all one more than multiples of 6. So we could try something like 667 and see whether green lights up.
Oh, it's having to think a little bit.
Sorry.
Yeah. Maybe we should go for a smaller number, and then it'll be a little bit quicker. We might have to be a bit patient now. There we go.
And it has a green now.
Well done. Well done, Elizabeth. Fantastic.
So we could use the answer and check that?
Yes. Okay, let's do that.
For those of you who've been using the site, we are planning to speed it up. Apologies if it's frustrating you. We're going for green, not blue, Liz.
Thank you.
One
more than a multiple of 6.
And if it's one more than a multiple of 6, then it's also 5 less than the next multiple of 6.
Exactly.
If you see what I mean.
I do see what you mean.
Okay.
Great. Okay.
And we could do something similar for yellow and for blue.
We could carry on. I like this though, Charlie. I mean, seeing the bulbs light up really wants me to be able to figure out why. When are these bulbs lighting up? Why? And we could, it's motivating. It's motivating.
And getting feedback is really quite reassuring.
Absolutely.
And one question we can now start asking is, well, we know the rule for red, we know the rule for green.
Yeah.
Could I have both red and green light up?
At the same time.
And this is at the heart of the follow-up question.
Yeah.
So if we scroll to the bottom, there is a link to a little light thinking. So it's the same interactivity, except that here, instead of being able to check your answers, which we assume students have been able to do by now, there is a chance of having the results either tabulated or on number lines. So this is a new rule because it's been reset. And so let's see what happens.
Okay, shall I
now? So everyone who's participating, you don't need to keep a record anymore because the interactivity is going to do that for us. So go for it.
Oh, look, all of them have lit up at least once.
Green is lighting up
quite
very
frequently.
often.
Yeah. All right, nice. Okay. And so Charlie, you mentioned the lines. Can we have a little look at the
yes.
The image? Ooh.
And you can also scroll if you won't be able to
scroll yet until there are some numbers outside there.
Okay, there we are. So we can scroll.
Yeah.
If I can find the scroll bar.
There we go.
But it also means that, yes, what people might not realize is you can also go to the left of 0.
How lovely.
And so you've got negative numbers as well as positive numbers. So I find it much easier to work out what the rules are if I'm working with positive numbers.
Yes.
So
where should we start? Well, perhaps some of you participants would like to make some suggestions.
So it might be easier to look at the tables.
It might be.
Okay, there
that's nice. That's it.
There are 2 reds,
2 yellows, and several greens. 4 greens, in fact.
And if I tell you the blue appears at 15 as well.
4 and 15.
The yellow appears at 3 and 9.
I wonder whether anybody could express the rules of any of the light bulbs. We do have linear sequences, Elizabeth, yes.
Yeah, maybe we should have made that much clearer.
They are all linear sequences, yeah. We should have made that clear. So Juliet, thank you for your suggestion for greens. Juliet is suggesting 1 less than a multiple of 3. I think I would agree with you, or we could phrase that, couldn't we, as 2 more than a multiple of 3. Courtney is suggesting for yellow 3 less than a multiple of 6, or a bright. Thank you, Courtney, you did the work for me. Or 3 more than a multiple of 6. I agree. Fantastic. Any offers for red or blue? So I have posted in the chat some adjacent numbers that light up the lights. Red is lit up by 4 and 11, blue by 4 and 15. Let me scroll this way a little bit. Elizabeth, thank you. So Elizabeth, you're suggesting 7 less than a multiple of 11 or 4 more than a multiple of 11. I agree. Yep. And so I think we've just got red to go. So red lights up the numbers 4 and 11. So I think those might be 7 apart. So I think those are going to be 4 more than a multiple of 7 or 3 less than a multiple of 7, perhaps. So Charlie, this I think is leading to some potentially rather nice situations, rather nice questions about lighting up 2 lights at the same time, perhaps. What do we think?
Can we share my visualizer? I've been
indeed
trying to figure things out.
Charlie has been creating a very comprehensive table. I'm going to share the piece of paper on which Charlie's been working.
My sheet of paper isn't quite long enough, but I've got a record there. And I think I can work out when red and blues are going to light up, because they both lit up at 4.
Mm-hmm.
Now, blues are going up in 11s and reds are going up in 7s. So if I keep going up in 7s and I do 11 steps of 7, so I keep going, after 11 steps, I will have added 77.
Yeah.
And if I add 77 to 4, I'm going to get 81.
Yeah.
Now in this one, because it starts in the same place, if I just do, oh, yes, if I do 7,
you beautifully
I've got
illustrated it already. Yeah.
There's 81. And I can predict that because I will be doing a jump lots of jumps equivalent to 77, because I'm going up in 11, and I'm going to be doing lots of jumps which are going to be equivalent to 77 here, because I'm going up in 7s.
Yeah.
So I think if I add another 77,
you'll be in a position again for them both to light up.
Does that make 158?
Oh, good question. Yes, it does. Yes.
So we can check that, but I think red and blue will add up at 158.
Okay.
But I also have a conjecture, which is that yellow and green will never, ever add up light up at the same time.
Shall we invite participants to think about that for a moment?
Okay, yeah, because you could use my sheet if this is at all helpful.
So Charlie's conjecture is that yellow and green will never light up at the same time.
So I think I've got a smiley face there, but yellow and green, that fitting? Not quite there. I'm going to have a sort of sad face. I don't think yellow and green can light up.
Okay. So we've got a few people who seem to be agreeing with Charlie. We've had an offer of an explanation. 30
Yeah,
seconds
so
more, or are you going to?
Can we just see who wrote multiple?
It was Elizabeth.
Okay, so yeah, I think Elizabeth has spotted that if I have a multiple of 6, then that is an even number, which is a multiple of 3.
Yeah.
So if I add 3 to that,
yeah,
I will get another multiple of 3.
Absolutely.
Actually, I'm going to get all the odd multiples of 3. But the green rule is that you're not going to get a multiple of 3. You're going to get 2 more than a multiple of 3. So I can't have a multiple of 3 and 2 more.
No. So I think we have reasoned through, and we agree with you, Charlie.
So I think that's all I want to do at this stage.
Yeah.
Hopefully that whets your appetite in terms of giving you a sense of the kind of questions that these interactivities allow us to.
Yeah, absolutely.
And the kind of discussions and the kind of reasoning. And I mean, we didn't set this up in advance, so we were really lucky to have 2 examples, one that worked and one that didn't.
But having said that, Charlie, I think just before we move on to another problem, we should draw attention to, in the cog, if you click on the settings, the purple cog, you can, if you would like all students to be working on the same setup, maybe at tablets and pairs, then you can create the code yourself. So the first 2 numbers, now that we've worked on that, I'm sure it wouldn't take you long to figure out. The first 2 numbers refer to the top light, the yellow light, 3 being the first number above 0, the first positive number that lights up the light, and the second number being the second positive number that lights up the yellow. And then the next 2 numbers refer to the same for red, and then green, and then blue. So you could set up your own code so that all students would be working on the same setup, should you wish. Okay, so Charlie, shall we have another go at a different task?
Okay.
Yeah.
So can we go back?
Where are we going next?
Let's go back to the mapping document, please.
Okay, I think I've got that here. Yeah.
Let's go to the number page rather than the algebra page. And there's a nice little problem in the number operations and calculation
I'll scroll down.
Here. Number operation calculation methods. And I quite like the problem on the left, on the first column, called consecutive 7.
Okay, consecutive 7. Right. Here we go. Let me make this a bit bigger.
So the question is, I've got these 21 numbers, so from 0 to 20. And the challenge is, can we arrange these numbers into 7 sets, each set with 3 numbers? So 21 numbers altogether, split them up into 7 sets, each set with 3 numbers. And when I add the 3 numbers in each set, I end up with 7 different totals. And the totals are all consecutive numbers.
Okay.
So I'm wondering whether you might want to think about this list, but also if anybody who's participating would like to suggest how to do this. If we did this with students, I'm imagining they would sort of approach this in a very unsystematic way. But since we've got teachers with us, perhaps the challenge for you is, can you do this in an elegant, efficient way? And just to give you a flavor of what I mean, Imagine that instead of giving you 21 numbers, I gave you 300 consecutive numbers.
Oh.
So from 0 to 299.
Yes.
Could you arrange them into 100 sets of 3 numbers in such a way that when you added the 3 numbers in each set, you end up with 100 consecutive numbers in total?
Wow. So you think that's where we're going to be able to get?
So I'm looking for an elegant, efficient method that is transferable. That's what would be really...
That's what mathematicians like to do, isn't it?
Yes.
Yeah. Okay. Okay. So should we give everybody a chance to think?
Okay. Again, I don't want to spend a lot of time on this, but some people, I'm just looking at Elizabeth's solution currently. And what Elizabeth seems to have done is taken the first number in this first row, the 0, with the last number in the second row, 13. So 0 and 13 add up to 13. And then the second number in the first row and the penultimate number in the second row, so 1 and 12, also add up to 13. And she's carried on like that. So 2 and 11 is 13, 3 and 10 is 13, 4 and 9 is 13. So let's put them all into different sets. And so we've got 7 sets, all with numbers, with pairs of numbers that add up to 13. And then she's taken the 40, 50, 60, 70, 80, 90, and 20 and popped them into 7 different sets. And that will make the total consecutive numbers.
Absolutely.
Because the first 2 numbers sort of gave her
the same
the
total.
same. And all of a sudden I can see, oh, I could do that.
Yeah, and Noel here has done exactly the same, except that they have paired
0 and 10,
that's
1
right.
and 19.
Yep.
So numbers in the top row and numbers in the bottom. So smallest in the top row, largest in the bottom row, and then stuck the numbers from the middle row, 1 in each.
Right.
And there are variations on that could be there. So I can imagine doing this. How many different variations can you find? How many? And then all of a sudden you could see that if I gave you all the numbers from 0 to 299, you could use these strategies.
Same methods.
So yeah, it's not immediately obvious that this is going to happen, that it's going to be possible to do. Would you be able to do it? So here we got the numbers from 0 to 20. If we had the numbers from 0 to 23 and so on, would you? Can we do it with any multiple of 3 consecutive numbers? There are questions that are sort of popping up here.
Yes. Yeah. A good opportunity for students to ask their own questions as well. Yeah.
Yes. I mean, I haven't thought about this, but if the total number of numbers was a multiple of 4, and I'd organize them into 4 rows, you know, am I able to adapt my method?
Yes.
Is this always going to be possible that I can split it up into, you know, if I had, for example, 32 numbers, I've got 8 lots of 4. Can I make 8 sets of 4 consecutive numbers, which is where the total, and I don't know the answer to that. But the idea that each problem is a springboard to other questions.
Right.
And I know that when you and I work with students, and the students have solved a problem, we might sometimes say to them, right, what do you think mathematicians ask themselves next? Yeah. I think that's a brilliant question to be asking. What else might we explore now that we've sort of got our heads around this problem?
Absolutely.
And I think that's a good question to have up our sleeves when we're in the classroom. But we need to move on.
Okay, where now then, Charlie?
Where are we? Consecutive 7. I think I'd like to do something about area and perimeter, I think.
So back to the mapping document.
Let's go back to the mapping document.
Yeah, we'll just make it a bit smaller again.
And let's go to the
so we want to go to the
geometry page.
Yeah.
And there'll be a section on area and perimeter.
Okay, scroll down a bit. Area, perimeter, area, and volume. Here
and I think there's a section called perimeter possibilities.
Oh yeah, here we go. Problem perimeter possibilities.
Actually, I think I might do some scribbling on the sheet.
Okay, right.
Do you want to?
Yeah, I'll share the visualizer again.
Brilliant.
There we go. Okay.
So I want you to imagine we have a rectangle.
Yeah.
And the area is going to be 24.
Okay.
And the area is going to be 24.
Okay.
And let's imagine that the perimeter is 20. Can you tell me what the width and the height are going to be?
I'll do my best, Charlie. So if I've got an area of 24, I want 2 numbers that multiply together to make 24. So let me think about some factors of 24 here. Okay. So 1 and 24. Now I want these. If I want the perimeter to be 20, I would like half. Therefore, half the perimeter is going to be 10. So I'd like my 2 side lengths to add to 10. I think so. Right. 1 and 24 definitely don't add to 10. 2 and 12, no. 3 and 8, no. 4 and 6. Okay.
Now,
got there eventually.
No, I'd be, I'd be delighted if students worked as methodically and systematically as you do. So I might then ask you for perimeters of 22, perimeters of 28, perimeters of 50, always with an area of 24.
So I think I would do a similar thing and think about the factors.
And very quickly, I imagine you'd get 3 by 8, 2 by 12.
Okay, yeah.
And 1 by 24.
Yes. Okay. Yeah. Yeah.
We might ask students something about what do they notice. And when I've done this with students, they might notice that the first shape is sort of quite boxy.
Yes.
But then they become slightly
more elongated,
longer and narrower. And so there's something there. The perimeter
is increasing as you get.
It's getting large. So yes. So and also the perimeter is always even. So there's lots of questions that one could ask students in the, what do you notice and why do you think this is happening? And then this could lead to other questions like, well, can the perimeter ever be an odd number? It doesn't look like it, does it? But I think I'm going to challenge everybody who's here. I think it might be possible to have a perimeter of 35. So can anyone help Liz
I do need help here, please.
What is the width and the height if the perimeter is 35? And one thing to be thinking about is how can you use everything that might have been discussed at an earlier stage? I talk about polar bears and snakes sometimes. So something very boxy is like
Oh,
the
like
4
a
by 6.
polar bear. Oh, I've never heard that before. Right.
Well, if you live in a very cold climate,
yes,
you want to have as little surface area exposed to the cold air. So you want to be as spherical as possible.
Yes.
Whereas if you live in a hot climate and you're a snake in a jungle, you want to be able to
Cool down.
Yes.
Maximize yourself.
So if you have a perimeter of 35, it's somewhere between 28 and 50. So it's slightly more snake-like than 28, but slightly more polar bear-like than 50.
Yeah.
So somewhere between 2 by 12 and 1 by 24. And Elizabeth has suggested what might be the answer. And if we think about sticking the 35 in there, then we're looking for an answer between 1 and 2. And so 1.5
would be a good place to start.
By 16 will give us areas of 24.
Nice.
Now, I think let's perhaps stop sharing.
Yeah.
I think one of the things about a problem like this is that then I imagine I would get students working in pairs.
Yeah.
Where they each think about a rectangle, they think about the area of the perimeter, and they give it to each other.
Right. So they're not relying on a textbook, or there's something rather nice about being challenged by your peer.
Absolutely. If you give me a problem, I still don't want to be beaten by your problem. I want to work out the answer to your question. And if you've given me a really difficult one, I'm going to give you a difficult one next
You'll get revenge.
So there is something nice about being able to. So in everything we've done so far, it's the mathematics that's been intriguing and has led to curiosity in asking questions. Sometimes the way that we present problems can make the problem more engaging. I'm more curious about the rectangle that you're thinking about if you've thought about it than if some random person who's written a textbook who I've never met has thought about it.
Absolutely.
So that is part of curiosity. Now, I'd quite like to go to the problem.
Yes.
Can we go back to the website?
Let's go to the site. Yeah.
Because I think there are 2 lovely questions, follow-up questions, that I'd like everyone to think about.
Okay.
Now, of course, and apologies that we're rushing through this. And of course, with students, you go much slower. And every problem does have teachers' resources where we suggest how the problem can be used in. I'm going to enlarge it even more. My question is this: is it possible to make a rectangle with a fractional perimeter but a whole number area? Is it possible to make a rectangle with a whole number perimeter but a fractional area?
This just seems, my gut reaction is no.
Both seem impossible.
No, it's not possible, Charlie.
Okay. But I never give you impossible. Problems are impossible to answer.
Well, I'm not rising to that challenge. No.
Okay,
this is really lovely, though. Really lovely.
So you might want to. Shall we give everyone a minute just perhaps to think about this? Or perhaps I don't give anybody any time, but I'm not going to answer the question.
Okay, all right.
But this is the problem called perimeter possibilities. There will be a link to it. You can think about it. Despite Liz's gut instinct that both are impossible, in this case, both are possible. So that's a nice opportunity to think about perimeter and area.
Really nice.
I mean, I suspect many of you have thought about, can I have a rectangle where the perimeter is larger than the area?
Yes, that's more of a classic.
Can I have area greater than perimeter? Can I have area equal to perimeter? Now, a lot of people know about 4 by 4 square and the 3 by 6 rectangle, but perhaps not so much about, for example, 10 by 2.5, where the perimeter is 25 and the area is 25.
Now,
or I think 18 by 2.25. where, I don't know, I think the perimeter area are both 40.5. But there are, and that could be the start of doing some algebra here.
Yes, yes.
And there are questions about why one of the lengths of, neither length could be less than 2. And there are sort of thought-provoking questions that mathematicians might be interested in. But we need to move on.
Let's move on. Okay, where are we going next? Back to the mapping document? Or?
Yeah, let's go to the mapping document. No, let's not go to the mapping document.
Okay.
Let's go to a problem called tilted squares.
All right.
And I'm going to spend very little time on this, because a lot of you perhaps know this problem. Let me just make it a bit smaller. And just in case some people don't know it, I just want to draw attention to the fact that we've got a problem called tilted squares. And one of the things you could do with students is say, oh, look, you know how to work out the area of a square like that. Got an area of 1, 2 by 2's got an area of 4, 3 by 3's got an area of 9, 4 by 4, 6, and so on. But what happens if I give you a tilted square, so that to get from one vertex to another, you go to, now, some students might think, well, I don't know how to work out the area of that. So in the problem, apart from having teachers' resources, we do have some help for students.
Yes.
And we could be encouraging to either box in their tilted square or split the square up into smaller square and some right-angle triangles.
Both of which are very accessible methods,
Yes. So let's get back to the problem. But you can imagine what we might do is we might suggest we start looking at squares like this. And students could work out the areas. And then when we gather the information together, they might find that this, which is 2 across and 1 up, has got an area of 5. This one that's got a sort of 3 across and 1 up has got an area of 10, and then 17 and 26 and then 37. And again, what is happening here?
5, 10, 17,
26, and 37. What do you notice about those numbers, Liz?
I think they're one more than a square number.
They're one more than a square number. And, you know, is that right? So if I go 10 across and 1 up, can I box that in? Am I going to get 101? I can check. This is really good mathematical thinking, conjecturing, generalizing, and working out the areas of squares and triangles. Like you say, this is an accessible problem. And then what would mathematicians ask themselves next? Well, what would happen if I go 2 across and 2 up? And 3 across and 2 up, and 4 across and 2. Look, eventually, I'm going to give the game away here, I'm afraid. Eventually, they'll discover Pythagoras' theorem.
But for themselves.
But they will be able to do this at a much younger age than Pythagoras often appears in the curriculum, and they will discover it for themselves, which is rather wonderful. Okay, are we going to have time for one last problem? No.
I don't think we are, Charlie, unfortunately, but we hope. I'm going to take you now to the menu again up here. We hope what we've done is given you a bit of a commentary about different ways that problems can nurture students' curiosity. Now, let's go back to the secondary teacher homepage to give you, just to remind you, what we have done is we've created some written guidance. So if I go to the Developing Positive Attitudes section and I click on the Being Curious link, you will find, first of all, you'll find a whole range of tasks linked to their approximate age group. So please do go and explore those. But here,
so these are problems in the mapping document.
Yeah. So they're curriculum linked problems.
And like the problem that we've just done, which are about place value or about sequences, geometry, or about, we never did anything on statistics. But yes, okay.
But we have particularly selected them because we feel they're really good for helping to nurture students' curiosity as well. So those are the groups of tasks. But here in the blue box, you've got a link to some written guidance that we've created to kind of summarize what we've been talking about today. So do take a look at this. We will make sure that in this guidance, we will link to all the problems we've looked at in the webinar, and there are others too. So there is plenty to keep you going. Now, we did say right at the beginning that,
can I just add, and in the next few days or at the beginning of next week, a link to the recording of this webinar will appear at the top.
The top of this page.
So if you want your colleagues to think about curiosity or want to watch a bit of the webinar, they'll be able to access this at the top of this page.
Exactly. Yeah. Thanks, Charlie. I forgot about that. And just as a reminder, we mentioned that this is, one of many webinars that we've been running recently. Probably the quickest way to find all of them is to go to our Problem Solving Schools menu, to the bottom link, Resources and Professional Development. And we go, let me go a bit smaller, just to make it a bit clearer. There we go. Clicking on any of these are our 5 mathematical thinking skills. Clicking up on any of those takes you to the guidance page, and at the top of the guidance page are the links to the webinar recordings. And of course, here you've got the curiosity guidance, and that is what we've just been looking at, where it will have a link to the recording in due course.
And in the next few months, we'll be doing webinars. Well, we're producing some guidance, and then there'll be the accompanying webinar, and the next one's going to be in early May. Yes,
the next one is on 7th of May for secondary teachers, and we're focusing on being resourceful. Yes, so do join us then if you can. All the details will be on our events page in the next few weeks.
Yes, and you can access the events page through the teachers.
Yes. What I'm going to do is I'm going to post up a link to a feedback form into the chat. We would really appreciate you taking a moment to fill it in, please, if you can. It helps us feedback to our funders, and it helps us to do a better job as well.
Can I answer Penny's question?
Oh, yeah. What is Penny's question?
Because I think, if I understand what Penny is asking, is whether, do you envisage that exploring these problems fits within explicit teaching of the curriculum to which it is linked, or better standing out of context?
Oh, good question.
Can we just go to, are we sharing the screen?
We're still sharing the screen.
Can you just share one of the problems? Wipeout, for example, is there?
Yeah. So this is one of the problems that we didn't have time to have a look at.
So, can we bring it down? The chat?
Sorry, yeah.
So I just want to.
Sorry, things are getting in the way on my screen. That's there we go.
Okay, so Penny, but everybody else, this is really important. This problem that we didn't have a chance to think about, but we do recommend, here tells you that it's suitable for 11 to 16-year-olds. 2 stars means it's slightly more difficult than a 1-star problem, but not as difficult as a 3-star problem, and that it's particularly useful if you're doing some work on statistics.
Yeah.
Now, because we've also tagged the problems to highlight which mathematical thinking skills they link up to, but also which mindset. And this now appears, this is something new, this now appears whenever you see a problem. We're not suggesting that you're going to drop everything you're doing in the curriculum and just focus on curiosity for a week or two. But we are suggesting that perhaps when you're doing this problem, because you've got these sort of traffic lights shining, it might draw attention to you that, oh, this is a good opportunity to talk about working systematically, to use the language of conjecturing and generalizing, but also to know that this is a problem about curiosity. And so you go into the classroom with that kind of mindset. And if it says it's about being resilient, well, that might mean that, students are going to have to be prepared to sort of struggle a little bit. So you might get them working in pairs, for example, or there may be more sharing. So I think realistically, most teachers have got a curriculum
that they're working from, absolutely.
A scheme of work. But what this does is allows you to appreciate that these are opportunities to flex those thinking skills and to nurture those positive attitudes. So we hope that this traffic light system, it helps in that way. I hope I've understood your question, Penny, and that helps.
Thank you all very much indeed. I think at this point we're going to stop recording, and we wish you a very good rest of your day. And we hope to see you at a future webinar. Thank you all very much indeed.